Okay. So let's do an example of this. All right, so we're going to calculate the arc length and say f of x, which is going to be x cubed divided by 3, and then plus 1 divided by 4x, with 1 being less than or equal to x, which is going to be less than or equal to 2. Okay, so the first thing that we want to do is we want to take its derivative. Okay, so f prime of x, okay, so x cubed becomes 3x squared, so this becomes x squared. Derivative of 1 divided by x is going to be negative 1 divided by 4x squared. Okay, so we calculated the derivative. And now we're going to use the formula, which would be the integral from 1 to 2 of the square root of now 1 plus x squared minus 1 divided by 4x squared squared, and this is going to be an integral with respect to x. Right? Okay. So from this one, let's go ahead and let's square it. So that's going to equal the integral from 1 to 2 of the square root. Okay, now x to the 4th is an easy one. Now you have to think about the problem in terms of this. When I multiplied x squared by 1 over 4x squared, what's going to happen is the x squareds are going to cancel each other out until you'll end up with a negative 1 divided by 4. Well, this will end up happening twice. Okay? So we have negative 1 over 4 and negative 1 over 4. And that becomes a negative 1 divided by 2, and then plus 1 divided by 16 x to the 4th dx. Okay. Now, this negative 1/2 that is appearing right here, it's very important. Okay. It shows up on a lot of these problems. Not always, but a lot of these problems. So the reason that it shows up is because we have a negative 1/2 right here, and we have a positive 1 right here. So that positive 1 in the negative 1/2 will turn that into a positive 1/2. Okay. So that ends up becoming the integral from 1 to 2 of the square root. That's going to be x to the 4th, and then plus 1/2, and then plus 1 divided by 16x to the 4th. Okay, so the reason that negative 1/2 is so important is because now we have a positive 1/2, and what we can do is we can unfoil this basically, okay? And what that allows us to do is get rid of this square root sign. So this will equal the integral from 1 to 2 of the square root of x squared plus 1 divided by 4x squared squared, an integral with respect to x. Okay? All right, now the square root and the square cancel each other out, and so this becomes the integral from 1 to 2 of just x squared plus 1 divided by 4x squared, and this is an integral with respect to x. Okay, so that becomes x cubed divided by 3, and then minus 1 divided by 4x, evaluating at 1 and at 2. Now, one thing that I want y'all to notice is this looks extremely similar to what we actually began with, okay? So what was the original function that we were integrating? I mean, that we were trying to calculate its arc length? Okay, so we got to that point right there. You see, what we began with was x cubed plus 1 divided by 4x, and when we get down to the end, yeah, it's going to be the same thing, but it's going to have the plus is going to become a minus, or if there's a minus, it's going to become a plus. Okay? So, this will equal, now 2 cubed divided by 3 minus 1 divided by 4 times 2, and then minus, let's put a big parentheses. That would become 1 cubed divided by 3 minus 1 divided by 4 times 1. Okay. And in my class, it's perfectly acceptable if you want to leave the answers like that. That is an acceptable answer. It is correct. But if you start simplifying things and you mess it up, then I'm going to have to take a point off.